All right, so today we're going to go to section 3.2, section 2 of chapter 3, talking about synthetic division. All right, so we went over operations as far as going over the type of operations where we are adding, subtracting, and multiplying polynomials. This is a way for us to divide polynomials. Now with synthetic division, this is only when we're dividing by a binomial, one of the form x plus c or x minus c. All right, so our divisors are the number that we're dividing by, always has to be a binomial. Our dividend, the number that's being divided, is a polynomial. So our first example, we're given 5x cubed minus 6x squared minus 28x minus 2. And this is being divided by the binomial x plus 2. All right, so like I said, first things first, we want to make sure that the number that we're dividing by is a binomial of the form x plus a number or x minus a number. Our dividend, the number that we're dividing into, needs to be written in descending order. Our highest exponent first, constant last, because technically our constant is x to the 0 power, or we have no x's. All right. We also want to make sure that we're accounting for every degree. So if we start with x cubed, the next term should be x squared, x to the first, and then x to the 0 on my constant term. All right. If we're missing a degree, we have to account for it by plugging in 0 x's in that placeholder. Now, the way that we do our synthetic division, if we think about it, we think back to long division, technically what we're doing with long division is dividing and subtracting. So with synthetic division, it's actually the reverse. We're going to be adding and multiplying. So what we're going to do is take the value in our binomial and our dividend. Here we see positive 2. We're going to take the opposite of what we see and set it up in our synthetic division bar. Right, so we see positive 2, we'll put a negative 2 on the outside. Then we're going to account for all the degree, or excuse me, account for all the coefficients in front of the x terms. So we're going to have 5, negative 6, negative 28, and 2. Oh, I'm sorry, negative 2. All right. So those are the coefficients in front of the x terms. We have 5 representing our x cubed, negative 6 representing our x squared, negative 28 representing our x's, and negative 2 is going to be representing our constants. So with synthetic division, what we're going to do is bring down that first term, or you can think of it as plugging in a 0 here. 5 plus 0 gives me 5. So we're adding vertically, multiplying diagonally. So 5 plus 0 is equal to 5, or we're bringing down that first 5. Multiplying diagonally, 5 times negative 2, give me a negative 10. That goes right in my next column. Negative 6 plus a negative 10 gives me a negative 16. Negative 16 times negative 2 gives me a positive 32. Negative 28 plus 32 gives me a positive 4. 4 times negative 2 gives me a negative 8. And negative 2 plus a negative 8 gives me negative 10. All right, now this last value represents our remainder. And that's going to come up in a couple different ways later on in the section. All right, but this, once again, this is our dividend, this is our divisor. These numbers on the bottom represent our quotient or our answer. Now, if our dividend starts with x cubed, my quotient or my answer starts off 1 degree less. All right, so just like this 5 represents the 5x cubed column, this 5 is going to represent 5x squared. So this will be 5x squared minus 16x plus 4. That'll be my answer, starting 1 degree less. 5x squared minus 16x plus 4. And it also has a remainder of negative 10. Right. Now that's one way that we could present our answer. At least that's one way they present the answer dealing with that particular remainder. Another way that we can handle it is that we simply take the remainder, in this case, -10, put it over our divisor, which is x plus 2. So another way we could put it, 5x squared minus 16x plus 4, and -10 divided by x plus 2. That's another way they can present that exact same answer. And when you're doing the homework on the computer, it'll ask you to present it in both ways. All right. Any questions on that first example? More the same. This time we're given 4x cubed minus 15x squared plus 11x minus 10. And this is being divided by x minus 3. All right, so when we're setting up our synthetic division, remember, one, we want to make sure if we're doing synthetic division, that we're dividing by a binomial of the form x plus some number or x minus a number. This obviously matches form. So when we set it up, we're going to take the opposite of what we see. We see -3. So when we set it up, we're going to put a positive 3 on the outside. Then we're going to account for all of the quotient, account for all of the coefficients for each term in my dividend, making sure that we're accounting for every x. So here it starts with x cubed, x squared, x to the first, constant term, so we don't have any missing degrees. So we can put our coefficients out front, coefficients inside our synthetic division. So we have 4, -15, positive 11, and a -10. We're going to bring down that first term, keeping in mind that this represents our quotient. Our quotient starts off 1 degree less than our dividend. So our dividend starts with x cubed, our quotient is going to start with x squared. Adding vertically, multiply diagonally, 4 plus 0, 4. 4 times 3 gives me a positive 12. -15 plus 12 gives me a -3. -3 times positive 3 gives me a -9. Positive 11 plus a -9 gives me a positive 2. 2 times 3 gives me 6. -10 plus 6 gives me a remainder of -4. So our answer, remember, keep in mind it starts off 1 degree less. It's going to be 4x squared minus 3x plus 2 with a remainder of -4. Another way for us to present that remainder, -4 over x minus 3. All right. Remember, our remainder is -4. Just like in the last problem, our remainder was -10. Another way to present the remainder is to simply take the remainder itself and put it over our dividend, our divisor, x plus 2. So here my divisor was x minus 3. So I'll take that same remainder, -4, put it over my divisor, x minus 3. All right, another one like it. This time we do a 5x cubed minus 6x squared plus 3x. It's been divided by x minus 1. So when we're setting this up, we want to make sure that it matches form. By that I mean my divisor is x plus a number or x minus a number. This does match form. We're going to take the opposite of what we see for our number. We see -1. So we're going to put a positive 1 on synthetic division. And make sure that we account for every degree here. So we're starting with 5x cubed, or x cubed, x squared, x. This time we're actually missing a constant term. So in order for us to account for that missing constant term, we're going to plug in a 0 in our coefficients. So we're going to have 5, -6, 3, and 0. And this is because we don't have a constant. This is actually the most common mistake that I see people make when doing these synthetic division. They forget to account for any missing degrees. This is also inclusive if we don't have a constant. All right, so we account for that missing degree, or we plug in our zeros, and now we just set up our synthetic division like we did in the previous examples. 5 plus 0 is 5, or we could bring down that very first term. 5 times 1 gives me 5. -6 plus 5 gives me a -1. -1 times 1 gives me another -1. 3 plus a -1 gives me +2. 2 times 1 gives me 2. And 0 plus 2 gives me the remainder of 2. All right, keeping in mind our answer starts off 1 degree less. So if our dividend started with x cubed, my answer starts off with x squared. So we have 5x squared minus x plus 2 with a remainder of 2. Or another way we can present that remainder, 2 over x minus 1. All right, any questions on those first few examples? All right, so we understand how the synthetic division works. Keep in mind now, that these are matched form. By it, I mean the divisor or what we divided by has to be x plus a number or x minus a number. And we want to make sure that we're accounting for every degree. Those are the two common mistakes outside of writing the opposite of what you see too. Like we see -1 here, +1, -3 here, +3, +2, -2. All right, next thing we need to go over is the remainder theorem. And the remainder theorem is a quick way of us evaluating a function using synthetic division as opposed to just substitution. That's what the remainder theorem states. All right, so the remainder theorem says that if f of x is divided by x minus k, which simply means that it matches form for synthetic division, then the remainder is equal to f of k. Notice that in the divisor on our form, we see -k. For the remainder theorem, we see f of k itself. So just like it is with synthetic division, we're going to take the opposite of what we see in our divisor, and that's going to be equal to our f of that value k here. All right. So a quick example of this. Well, you know what I'm gonna flip over. Is anybody who's still copying down the remainder theorem? All right, so we're given the function f of x, which is equal to -3x to the fourth minus -3x to the fourth plus 15x cubed minus 50x plus 25. And we're asked to see what f of 4 is. Now, obviously, one way that we can do this is to simply plug in 4 for every x in f of x and see what the value is. But we could also use the remainder theorem. The remainder theorem just says that we can set up our synthetic division, setting up our 4 on the outside, accounting for the coefficients and making sure that we account for every degree. So here we have -3, 15, 0, -50, 25. Just check if I understand. Is anybody out there who understands why I plugged in 0 between 15 and -50? Because we don't have an x squared term. Like I said, that's the most common mistake that I see. Make sure that you account for every degree. So here we're starting with x to the fourth, x cubed. There's no x squared term, so we must have plug in a 0 for the x squared term. -50 is the x's, and our constant is 25. Now we do want to remember that with the remainder theorem, once we do our synthetic division, whatever the remainder is the value of f of 4, which is exactly what we're asked to find. So we're going to set it up, bringing down our first value. Our -3 plus 0 is -3. -3 times +4 gives me -12. +15 plus a -12 leaves me with a positive 3. 3 times 4 gives me another positive 12, or a positive 12. 0 plus 12 gives me 12. 12 times 4 gives me 48. Negative 50 plus 48 will give me a negative 2. Negative 2 times positive 4 gives me a negative 8. And 25 plus a negative 8 gives me 17. Because 17 is my remainder, by the remainder theorem, f of 4 is equal to 17. All right. Any questions on how the remainder theorem works? Next thing we're going to talk about is a number of 0. Now remember, 0 is a number itself, but we actually have we actually call a certain type of number a 0 in type of problems like this. So in our notes, we just write it's a number of 0. And the way that we can tell is if we use synthetic division and the remainder is 0, then it is. All right. So the way we can tell if a number is a 0 for a certain polynomial is if the remainder of the synthetic division is 0 itself. Hence the name. That's why we call it a 0. So if we're given the function f of x is equal to 2x cubed minus 3x squared minus 18. And we're trying to see if k equals 2 is a 0. All right, so the way we'll set that up. Notice that this time they're giving us k, but they're not giving us the factor. So we don't have to take the opposite of what we see. Just like when they gave us 4, or we were asked to find f of 4, we didn't have to plug in negative 4 here because they didn't show us the factor. All right, so if they show us the factor, opposite of what we see. If they give us the value, or k itself, exactly what we see. So when we're setting this one up, we're going to put a positive 2 on the outside. And do we have any missing degrees here? We do. What degree is missing? The x term. So when we're listing our coefficients, we're going to have 2, negative 3, 0, and negative 18. I want to make sure that I know you're going to get tired of hearing me here. You're going to get tired of hearing me say this. Make sure that you're accounting for every degree. That's the most common mistake. If you miss a degree, you can't get it right, no matter how well you add, subtract, multiply. All right, so we're going to bring down our 2. 2 times 2 gives me 4. Negative 3 plus 4 gives me 1. 1 times 2 gives me another 2. 0 plus 2 gives me 2. 2 times 2 gives me 4. And negative 18 plus 4 gives me a negative 14 for my remainder. Is this a 0 of the polynomial? This is not a 0. All right, so that lets me know that positive 2, not a 0 for the polynomial 2x cubed minus 3x squared minus 18. Our next example we're asked is k equals negative 3, a 0, the polynomial f of x, which is x to the 4th minus 4x cubed, minus 14x squared plus 36x plus 45. All right, so anytime we're given a value for k, and we're asked to for 0, that should let us know to set up our synthetic division. Here they did not show us a factor, so we're just going to take k is equal to -3. I'm gonna take it exactly as it is, put our -3 outside of our synthetic division, and account for every degree. So we have x to the 4th, cubed, squared, x to the 1st, and a constant. We don't have any missing degrees. So we can put our coefficients: 1, -4, -14, +36, and +45 from our synthetic division. I'm gonna bring down the first one. So we have 1 times -3, which gives me -3. -4 minus 3 gives me -7. -7 times -3 gives me a +21. -14 plus 21 gives me a +7. 7 times -3 gives me a -21. 36 plus -21 gives me a +15. 15 times -3 gives me a -45. And +45 plus a -45 gives me 0 for my remainder. So is -3 a 0 for the polynomial f of x? This is a 0. And one more like it. Here we're given k is equal to 1. Trying to see is this is 0 for the function f of x, which is x cubed minus 4x squared plus 9x minus 6. So we're going to put a +1 on the outside of my synthetic division. I'm going to make sure that we're accounting for every degree. Do we have any missing degrees here? No missing degrees, so we don't have to worry about plugging in zeros. My coefficients: 1, -4, +9, and -6. So we're going to bring out our first one. 1 times 1 will give me 1. -4 plus 1 gives me -3. -3 times 1 gives me another -3. 9 plus -3 gives me 6. 6 times 1 gives me 6. And -6 plus 6 gives me 0. So is this a 0 of the polynomial? Yes, it is. All right. Now, these are the type of problems you're going to see for 3.2. Right now, we're on pace to take a third test the last day right before spring break. All right, I just want to kind of throw that out there. I like to try to give you guys at least a week ahead of time notice. Remember, we only have 4 sections in this in chapter 3. So right now we're on pace. This is 3.2. So we'll do 3.3 on Friday, 3.5 on Monday, review on Wednesday, test next Friday. All right. Be sure to sign up real quick for being here today. Questions? And give me about an hour to get the test results. All right. Guys, have a good day, and I'll see you on Friday. To my next. Test. How do you feel like you like, if I was you, what I would do is email me. Yeah, I just probably would tell me things, tell me so much. But next week,
I'll tell Mike. Well, just tell me that next